So, good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and Mastermind Schools. So, once again, welcome all the class 8th students. All the class 8 students for today's session. As you all can see on the screen and you are well aware, my subject is physics. We are in class 8. Our ongoing last chapter, heat. So we are entering into the session number 3. So far we completed 2 sessions in understanding the basic concept of heat. So we'll continue where we left in the last class. But before that, let us recall. Let us review what we learned so far in the chapter heat, right? So first we'll learn about what is heat. Then related term, that is temperature. And difference between heat and temperature. Right. Then we'll learn about the thermometer scales. What is thermometer? Scales of thermometer. The last class. Right. Again, relation between scales. Relation between scales of thermometer. Right. So later we'll discuss about after this. So after learning, we learned about all these things in the last class. Okay. We learn about what is heat. As you know, heat is a form of energy. Is also called thermal energy. Thermal energy, which is always travels from hot body to cold body. Right? Then, due to this heating cause, there is an effect called temperature. So, because we cannot see heat, so the effect is temperature, which is nothing but either hotness or coldness of a body. Hotness and coldness of a body is called temperature. And temperature is measured in Kelvin or Celsius, whereas heat is measured in, as it is a form of energy, we can measure it in joule or calorie. So where 1 joule is equal to 1 calorie is equal to 4.18 joule. Very important point. Then we have seen the differences also. What is the major difference between heat and temperatures? Okay. So we move forward and learn more about the heat and some of the important properties of the heat. Right. So before that, let me give one more information about the sources. So we need source. These are things all we have seen. So what are the scales of thermometers? Right. These are the scales of thermometer. What we learned. There are 4 scales are there. Mainly 3 is given here. Celsius scale, Fahrenheit scale, Kelvin scale, and Römer scale. So this all depends on their minimum measurement and maximum measurement. Whereas in case of Celsius scale, 0 is called lower fixed point, which is the minimum measurement. 100 is called upper fixed point, which is the maximum measurement. In Fahrenheit scale, 32 is the minimum, 212 is the maximum. In case of Kelvin scale, 273 is the minimum, 373 is the maximum. In case of Römer, 0 is minimum, 80 is maximum. Like that, we are seeing the 4 scales, 4 thermometer scales, temperature scales. You can see here, and there between the relationship between them is also given by the formula, by which you can convert the one scale into another. So this is a common formula between the 4 thermometers. Very important. C by 100 is equal to K minus 273 by 100, F minus 32 by 180, R by 80. R minus 0 is R1. So this is a relationship between all 4 thermometer scales. So when value is given in one scale, you can convert that into another very easily. So we'll come across the problems when you are doing the worked out problems, right? Then we have seen the video also. What is the absolute scale? Minus 273 degrees Celsius is called absolute temperature, is also called 0 Kelvin. Named after the scientist Kelvin, Lord Kelvin. Okay. Now, so that is only about the heat, temperature and thermometer scales. So we already learned even lower class also the same topics. Now we are going for the thermal expansion. Very interesting topic. Thermal expansion. Right? So the synopsis 3 we are here learning about the thermal expansion. You know, thermal is nothing but heat. Expansion means whenever you are heating any substance, whether it is a solids, liquids or gases, when they are heated, they'll expand or heating. Expansion is nothing but change in the shape, size, volume, right? So change of shape, size, volume is called expansion, right? So anything you can expand. Suppose you are expansion your business. What is my expansion? Going to some other places. Same company, when you going to other places, it is called expansion. If you see our group of schools started at one place and expanded throughout Telangana, Andhra Pradesh, that is called expansion of schools. Similarly, whenever any body is heated, any body is thermal energy increases, automatically they go for expansion. That is called thermal expansion. See here, the size of the most substances, solid, liquid and gases increases on heating and decreases on cooling. Agree, huh? When you are heating the either liquid, solid or gas, the size increases when you are heating. Size decreases when you are cooling. Contrast, expansion. Expand and contrast they are called. Expand means increasing. Contrast means decreasing. Okay. So expansion, contraction takes place when you are heating or cooling the body. That is called expansion, thermal expansion. Okay. Thermal expansion takes place in all bodies and in all three states of matter. Thermal expansion is reversible. So the expanded body returns to its original size on cooling. So when you are heating, body may increase the size. But when you are cooling, again comes back to normal. That's why it is called reversible. Thermal expansion is reversible. Got it or not? So very interesting point here. So all the states of matters, whether they are solid, liquid or gas, they undergo increase or decreasing of their size on heating. When they are heating, they are increased. When they are cooling, they are decreased. Right? So what we thought is all three states increases. So first we'll discuss about the expansion of solids. First discuss the solids, then liquids, then gases, because all the three have different shapes. This is solid. In solids, all the particles are tightly packed. It's very hard. Whereas in liquids, all the molecules are little apart from each other. Whereas in gases, they are so far from each other. So expansion rate, expansion speed is different in solids, liquids and gases. And the way of expansion also difference. So before going for the theoretical explanation, let me show you one video on the same expansion. So I can check the page numbers. I cannot explain the page number. You can open the book and see. Right here. So it is purely from your material only. You can open it and see. So before going for this, you can see the video on heat and expansion of heat, right?
Next topic we are having thermal expansion. See carefully what do you mean by thermal expansion. Thermal expansion means whenever we are going to heat up any solid or any substance, not only solid, each and every state of matter, either it is a solid, liquid or gaseous, each and every state of matter is going to show up the thermal expansion. What do you mean by it? See carefully. Whenever we are having any state of matter and we are going to heat up that state of matter, there is always a expansion of that material or that state of matter, and this expansion or the increase in the size of the substance is known as thermal expansion. This substance may be solid also, liquid also, as well as gaseous also. So one by one we will discuss about the thermal expansion in solid also. We will discuss it about the liquids as well as gaseous also. So firstly here we are having the thermal expansion in the solids. So as we know, a solid is always having a definite shape.
Listen carefully. Expansion of solid, okay?
And definite size, okay? And whenever we are heating the solid, whenever we are heating the definite shape and definite size, there is an expansion of solid in all directions. All direction means through the lengthwise also, through area wise also, and through the volume wise also. Here we are having one simple experiment.
Lengthwise, base, height wise, area wise, okay?
Experiment of thermal expansion using a Gravesend's ball and ring experiment. See carefully what is there in this experiment. This is the apparatus of this experiment. Actually, this is a ball which is at the normal temperature. Means this ball is now not heated up. This simple at room temperature ball is there. Whenever I am having the ball and I am going to pass the ball from this hole, this ball will easily pass from the hole. Okay? But yes, if I am taking the same ball and I am going to heat up the ball, whenever I am going to heat up the ball and same size of the hole is there, now this ball, after the heating up, this ball is not able to move from this hole. Why? Because whenever we are heating any solid, there is an expansion of the size of the solid. Due to expansion of size of the solid, now this ball is not able to move from this ring. That is why it shows us that whenever we are heating any solid, there is expansion in a solid. So this Gravesend's ring and experiment ball is there in order to show the thermal expansion in the solids. But yes, if we are having different solids will expand differently. For example, this I am having the wire or the rods of the two material. For example, this is the iron material, okay, and this is brass material. Whenever I am going to heat these both materials, these both solids are having the same length and same amount of heat I am going to give to this both the materials. You will observe that brass will expand more as compared to iron. So thermal expansion also depends from material to material or solid to solid. So this thermal expansion in a solid depends upon three factors. What are that three factors? See carefully. Firstly, it is going to depend upon the original dimensions of the solid. That what is the original length or what is the original area or what is the original volume of the solid. In that also it is going to depend the thermal expansion. And second, we are having rise in temperature. That how much temperature we are giving in order to expand it. That is also the considerable fact. Okay. And third, we are having the nature of solid material. As I already told.
These are the very three important points where the thermal expansion depends. You can note down also. So different solids expands differently. The one is original dimension of size. Suppose you have taken a small metal ball and big metal ball. Big one is having different size when compared to small. So big one will go for more expansion compared to the small one. Similarly, how much temperature you are applying, whether you are raising 10 degrees Celsius or 15 or 50, 100, based on that also expansion. Greater the temperature, greater the expansion. Then nature. Whether it is iron or brass or gold or silver, different materials will have different types of expansions, right? So you can note these points are very important points. The thermal expansion of solids depends on three factors. Number one, original dimension of solid. Number two, the rise in temperature. Number three, nature of solid material with which it is made up of, right? Just note down in the notebook as a synopsis. So expansion, thermal expansion is a heading. Already there. There are so many day-to-day examples of thermal expansion helpful in our day-to-day life that we'll discuss after completing the topic. Note. Okay.
Told in the previous slide that thermal expansion depends upon material to material. Different material expands differently. Now we will see that how thermal expansion of the solids are there
See,
according
observe
to its
carefully how the
molecular
molecules
motion, that
changes
how
inside.
molecules move, how molecules expand whenever we are heating any solid. For example, this I am having a solid, there is a molecular particles in the solid. Okay, these are the molecules in the solid, and the molecules of the solid are randomly moving around their mean position only, or going to move to and fro about their mean position only. But whenever I am giving the heat to this solid molecule, these molecules are going to move away from each other. These molecules firstly
As
take
they
the
gain
heat from the fire. After taking the heat from the fire, these molecules will strike on the walls of container. After striking on the walls of container, it will expand the size of the container. After expanding the size of the container, you will say that yes, there is an expansion in the solid. So in a molecules or in a solid, molecules are very closely packed to each other, as we already know. In the state of matter chapter, we have already discussed that there is a very compact arrangement or the tight arrangement in the solid molecules, but they are only just vibrating to and fro about their mean position. And whenever we are going to heat the solid, whenever we are giving the heat to the solid, the vibrational kinetic energy of the solid is going to increase. Means firstly they are increasing with a little bit speed, but now after gaining the heat, the kinetic energy between the molecules increases. Means whenever they are moving with a higher kinetic energy, they will push the force, or they will give the pressure to the walls of the solid. Whenever they are giving the pressure to the walls of the solid, they are just expanding in its size. By expanding in the size, there is a thermal expansion by gaining the heat.
Okay. So this is about the thermal expansion. Okay. Next, one more video is there, little more explanation about the same expansion only. You can watch.
So now we are going to see applications of thermal
So how it is
expansion.
useful
Means
in
in
our
our
daily
daily
life.
life, where we are going to see the thermal expansion. So very
Application.
first application we are having, while laying rail tracks, a small gap is left
Observe
between
very
two
carefully, gap.
successive rails. Why there is a small gap between the two successive rails? Because during summer there is a thermal expansion in the solid, and due to this thermal expansion in the solid, so that it can expand properly during summer, that is why some space is left between them. And if there is no space left between them, then there may be a cause of accidents due to the thermal expansion. So second application we are having, concrete
Second.
floors are laid in small blocks with a small gap between them. Means whenever two blocks are there in the tiles, these two tiles are having some space between them. Why they are having some space between them? Because during summer they have to expand. Means solid tiles have to expand so that it can
See,
take the
not crack.
space while expansion. That is why there is space left between the two tiles. Okay, but if yes, there is no space between the two tiles, then tiles are going to crack like this. That
See,
is why
because of
always
expansion,
whenever
they
there is a
crack.
lid or there is a formation of the tiles on the floor, there is always some spaces left between the tiles, so that in summer they can easily take up that space. And
You can go and observe at home, whether at your home, either in washroom or hall, the tiles are gapped or not. If they are cracking, means they are expanding, and they are cracking because there is no proper gap.
there is not the crack in the tiles. Next application of thermal expansion
Very
we are
important. You
having,
can see on the
in
road also.
summers, the telephone and electric cables are connected between the two poles are intentionally kept loose. Whenever
Loose.
between the two poles, these wires are kept intentionally loose. Why? Because as we know, during summer there is an expansion, and similarly in winters also there is a contraction of the solid, liquid or gas. Due to this contraction, they are intentionally kept loose, that whenever during winter they are going to contract, they will take the space and they can easily adjust itself, and they can contract easily without breaking or without snapping. Okay. So next
Interesting
application of thermal
application.
expansion we are having, that we are using the bimetallic strip in electric iron, electric geysers
It's a
and electric
bimetallic.
ovens. Why we are
Two
using
metals.
bimetallic strip? See carefully. Actually bimetallic strip is made up of two metals. Metals are brass as well as iron. For example, I'm using electric iron for the long time. Means whenever I'm using the electric iron, it will heat up very much obviously. But whenever I'm using for the long time, the bimetallic strip also is going to heaten up very much, and due to this heaten up bimetallic strip, the brass expand more as compared to iron. While taking thermal expansion, there is a thermal expansion in brass as well as in the iron. So brass expand more as compared to iron. Whenever there is an expansion of brass and iron, it will remove the contact between the electricity and the electric iron, which starts to cool down the electric iron. Okay. So whenever the electric iron is going to cool it down, it will again make the bimetallic strip in the straight manner. But yes, whenever we are cooling the bimetallic strip even below the room temperature, in that case brass contract more as compared to iron. Clear? So that is why bimetallic strips are used in thermostats for the automatic control of temperature in electric iron, electric ovens, geysers,
Geysers,
as well as
water
refrigerators
stop.
also,
Okay,
in order to maintain the temperature in these materials. Okay. Even though bimetallic strips are also used in MCB, that is miniature circuit breaker, which is used in our main electric board, so that we can just maintain the temperature flow which is coming from the main electric poles into our house. In order to maintain it, we are using the MCB, and MCB also use the bimetallic strip in order to maintain the temperature. So next application we are having, whenever we are having any kind of metal pipes through which hot water is going to move. As the water is hot, so due to hot or due to the heat, the thermal expansion is there in the metal pipe. So always there is a space left between this metal pipe, so that whenever hot liquid or any hot water is going to move from this metal pipe, it can easily adjust itself during the expansion. Okay. So metal pipes are used for carrying hot water, steam or other hot liquids, have joint in form of loops at regular intervals. Means whenever there is a change in temperature or even there is a contraction or expansion in the temperature, even whenever we are putting the hot water or cold water into the metal pipe, there is an expansion or contraction in the metal pipes. In order to adjust itself in the expansion or in the contraction, there is a small loops so that it can easily adjust into it. And if there is no loops at the regular intervals, then there may be a damage of the metal pipes. Metal pipes may damage also. Next application of thermal expansion we are having, whenever we are going to just put the hot tea or milk into the thin glass, that thin glass walls are going to break due to the hot milk or hot tea. Why? Because the inner side of the tumbler expand due to the rise in the temperature. Means whenever we are putting the hot tea into the thin glass, that thin glass is going to break. Why? Because from the hot thing or from the hot tea, it is going to expand from inside. Due to expansion, because inside there is an expansion but outside temperature is normal, due to this change in temperature, there is a always breaking in the material. So as the surrounding expands less and inside expand more, due to this different expansion between the inside and outside, there is a breaking of the glass. So next application of thermal expansion we are having, there is always a space left between the sealed bottle. This much space is left between the sealed bottle which is containing a liquid. Why? Because during summer there is a thermal expansion in the liquid, so that there is a space for the thermal expansion. It can easily take up the space and show the thermal expansion in the summer. But yes, if there is a no space between the sealed bottle, then this sealed bottle may burst during the summer season. Because if there is no space between the liquid molecules, then there is a no space for the expansion also, and expansion is not there, the bottle is going to burst during the summer. So next application we are having, the steel girders supporting a bridge are not fixed in the walls of pillars. Means these bridges are not fixed to the walls of the pillars, they are just mounted on the rollers. Why they are having rollers, these kind of rollers? Because during summer, as we know, bridge is going to expand, solid is always going to expand. Whenever during summer there is an expansion, it is having some expansion gap between it. Means whenever during summer it is going to expand, it can easily take up the expand. Means the roller can easily move the bridge and move to this side, so that it can easily take up the space during summer. There is no damage in the steel girder, or you can say on the bridge. So next application of thermal expansion we are having, in order to make the wheel of the Tonga, this iron rim diameter is always less as compared to this wooden wheel diameter. Why? Because and whenever we are going to fit this expanded ring on the wooden wheel, it is going to adjust itself. Means afterwards there is a cooling effect. Means they are pouring the cold water onto it, and after cooling effect there is a contraction. It can easily adjust to the wooden wheel. So iron rim of the wooden wheel of the Tonga are made little smaller in diameter as compared to wheel, because whenever in order to fit the iron rim into the wooden wheel, this iron rim is firstly going to heaten up. Due to heaten up, there is an expansion in the ring. After getting cold, this iron rim can easily adjust itself into the wooden wheel. Next application we are having, car tires are always filled with less air during summers. Why? Because as we know, during summer there is a thermal expansion in the solid, liquid as well as gaseous also. Why we are filling it with the less air? Because as we know, during summer there is an expansion in gaseous also. In order to prevent the tire from the bursting, we are just filling the car tires with the less air.
So enough. So many examples we are given. Right. So many examples of expansion of solids. Innumerable number of examples, around 10 examples of our day-to-day life. That both the videos can help you to understand what is exactly the thermal expansion, how it takes place, the expansion in solids, liquids or gases, or especially about solids, and what are the applications in our day-to-day life, starting from railway track, why the left gap is left, telephone wires gap is left, why some space in the liquid bottles, how the bridges are made with the rollers are kept. So many examples, even filling the hay during summer in our vehicles. All these are allowed to expand during the summer or contrast in the winter. They all are maintained as per the science only. So wonderful examples are given in the videos. So hope you all understood what is exactly the thermal expansion. But in this expansion, when you see among solids, liquids, and gases, so solids will undergo two kinds of expansion, three kinds of expansion. That is, one is lengthwise, one is area-wise, one is volume-wise. Whereas liquids and gases, as they does not have any shape, they undergo only one kind of expansion, that is volume-wise only. Correct or not? So the expansion of solids along lengthwise is called linear expansion. Along area is called area expansion. And along volume is called volume expansion. So for that, we have some equation, mathematical formula also, which we'll discuss in the next class, right? So these are the three kinds of expansions possible only in liquids. Only in solids. Whereas in liquids, it undergo only volume expansion, either liquids or gases. So that also we'll discuss in the next class, followed by the synopsis 4. That is, so far we are discussing synopsis 3, and some more information about the heat, what is specific heat, what is latent heat, and some definitions before ending the last chapter, followed by the solved examples. Right? Clear? So today we discussed only about what is thermal expansion, how it takes place in solids, what are the wonderful applications of thermal expansion of solids in our day-to-day life, or even liquids and gases also. So next class we'll discuss deep about the thermal expansion, how it takes place in solids. So in solids, the expansion takes place along the length, along the area, and along the volume. But whereas in liquids and gases, only volume-wise expansion can be seen. Right? So homework, learn more about the thermal expansion and try to solve the questions related to the thermal expansion. Right? So that's all for today. Thank you, all of you. So thank you, Medicine Oakley, for your wishes. So